Students, in the previous lecture we have started with the chapter that is motion of an object in a straight line. There we have understood the meaning of what is motion, what is a rest. These are the two states an object will show, and we can define it depending upon whether the object is changing its position and displacement with respect to the surrounding or not. Then we have studied about different types of motion. Whether the motion is a straight line one, it is rectilinear and translational. If it is circular one, then it is circular and rotatory. If it is showing a to and fro motion, then it is oscillatory or vibratory type of motion. In today's lecture, we are going to study the main content of this chapter. So, till now I have used the term object. But when we are concerned with this content, instead of just considering an object, we will take the object to be a point object. So what is meant by a point object, we will see here. A point object is an object wherein size of the object is very small with respect to what is the distance it travels. Means object whatever you observe, it may be of different size. It may be small, it may be large, and this comparison whatever we do, it is done with respect to the other car. If you are taking a car which is standing in front of you, for you when you compare its size with respect to you, it is larger. But the same car, when it is kept in front of a train or something, the size of that car will be small. So depending upon with respect to what you are considering its size, we have defined the object to be either point object, the other is a normal object. So we'll see the difference between them. Take example of two trains. They are passing across a track. They are passing a pole. They have different size. Means in one there are 5 compartments. In the second, there may be 7 compartments. So to pass the pole, the second train will take a larger time. The first train, since its size is smaller, it will pass the pole quicker than the second one. Similar trains, let they travel a larger distance, maybe some 300 to 400 kilometer of distance. In that case, they are moving with same speed and they are covering a larger distance. So when we study that concept, we are not concerned much about what is the size of that train. So where we are not much concerned about size of the object in comparison with the distance, then that type of object are considered to be as point objects. Here, the object size is considered to be as very small. In case of a normal object, whatever its actual size will be taken into consideration when we study motion of such objects. Then we are going to learn about a term that is known as a reference point. So whenever we are studying motion of some objects, we need to concentrate on term that is known as what? A reference point. Means with respect to what point I am studying motion of that particular object. That is considered to be as a reference point. So now take example of this point A. It is lying here. That is a point object. It is moving. It will shift its position from here and it will move to this point B. This is the motion of point A. It will shift here. Now, to study the motion, we need a reference point. Means with respect to this point, I am checking the position. That is, its position is changing. So therefore, let us consider another point O to be the reference point. Now, with respect to this point O, this has shifted its position from here till here. Therefore, this reference point, or it is also known as origin that origin is termed as what? Reference point. Okay, so it has been defined in this manner. It is the origin with respect to which the position of the object is represented. Whether it is lying along this direction, whether it is lying along this direction of the reference point, depending upon that, we are defining this term, reference point. Now, the term that is known as a frame of reference. So, we have basically two frames of references. One is known as inertial frame and the second is known as non-inertial frame. So, inertial frame is the frame, or it is nothing but the surrounding wherein we are studying motion of some objects. So, we will see what is meant by this frame of reference. So, here with respect to the origin, this object is moving along this particular manner. If that object is moving in a plane, then my x-axis and the y-axis will give you the reference frame for motion of this object. If the object is moving only along a straight line, so O is the origin, only along the x-axis. Now this is the frame of reference. So along this direction the object is moving. The same object, if it is thrown in space, then we have x, y, z, three coordinate axes to represent the motion of the object. So x coordinate, y coordinate and z coordinate with that reference point will give you the particular frame of reference. Now in a frame of reference, if the object is following Newton's laws of motion, then that frame is called as what? Inertial frame. In the other way, we have non-inertial frame wherein the object which is under motion, it not obeys the Newton's laws of motion. So we know there are three laws of motions. If object is not following those rules or those laws, then that frame is called as what? Non-inertial frame. Example is, just we will further classify or study what is the actual difference between these two terms, that is inertial and non-inertial frames. So for that, let us think that we are in a train which is moving. I have a ball in my hand. I throw that ball with certain speed. It will go and hit the wall. The train is moving with some constant velocity. Its velocity is not changing. So I know that this is the particular speed with which the object is moving. So I will calculate easily what is the distance it will travel, or in particular time it will go and hit the wall. You know the speed, I know the distance between the wall and me. So by using that, I can calculate what is the time of it. Means I have applied the Newton law here, Newton's relations here, and I could calculate the time. That frame wherein you are getting the actual result as you thought, or wherein the Newton law is actually applied, then that frame is called as what? Inertial frame. The second one, a non-inertial frame. Same example, but here the train, instead of moving with a constant speed, it picks up the speed. It moves with higher velocity. Now in that case, you have calculated the time period by applying the Newton's law mathematically. But since the train moves faster, the calculation whatever you do may not match with whatever things you observe. So here the Newton's laws are not valid. Therefore, that frame of reference is termed as non-inertial frame. So we have seen now the two frames. One is inertial and the other is what? Non-inertial frame. Now I have explained you about the motion as in a plane, in a straight line or in a space. So depending upon what dimension it moves, the object will show the motion. We have classified the motion into three types. One is one-dimensional motion, then two-dimensional, and the next is three-dimensional motion. So, to represent motion of an object, if we require only one coordinate, in that case, the motion is said to be one-dimensional. Example is, object is there, that is a point object being considered. It starts its motion from point A, O, and it moves along this direction, it reaches point A. Now here, the motion of the object is only along one particular direction, that is x direction. Therefore, in such case wherein the object is moving only along one direction, then that motion is termed as one-dimensional motion. In this case, I have taken the example for motion in two-dimensional, wherein the object is moving in a plane, that is x, y plane. So, when objects are moving in such a manner, then that type of motion is taken to be as motion of an object in two dimension. Example for it, I am walking in a ground. So, whatever motion I show, it is a two-dimensional motion. Object is moving here on this blackboard. Then that object's motion can be represented again with only two coordinates, x and y. Therefore, that type of motion is termed as what? Two-dimensional motion. And the third one is a three-dimensional motion, wherein to represent motion of such objects, we require how many dimensions? Three dimensions, x, y, z. Means in this case, the object is moving in a space. So, I throw object here. Now that object lies at a particular position. It moves from here to here. This is the direction of motion of the object. It shifts its position from A to B. Now to represent that in space, I require how many coordinates? 3. So one is x, other is y and z. So with respect to these three coordinates, when I represent motion of any object, then that type of motion is termed as three-dimensional motion. Okay. So we have just seen that depending upon the dimension of motion, we have three types. One is one-dimensional, two-dimensional and three-dimensional.